So today we're going to talk about the addition and subtraction of radicals. So last time we spoke about radicals in detail and their definition and how to simplify them. Today we're going to see how to add, subtract them, and also multiply them. Maybe also, let me see if we're going to do division as well. Okay, we're going to do division another time, so only multiplication today. So first let's start with addition and subtraction. All right, so when you add into, let's say, radicals, for example, this, and when you add into radicals like this, first thing you want to check, you must have the same number here inside, and also the same index. Okay, you gotta have, what's the index of these radicals, by the way? Everybody, what is the index here?
1, 2, 2.
2. The index is invisible, is 2. So you must have the same index, also the same radicand as we discussed last time, before you can add. After that, you're just going to add these two here. So you're going to do 3 plus 5. Radical 2, which is 8 radical 2. That applies to subtraction as well. Let's say you have a couple of radicals, maybe let's say 5 here, and maybe a cube instead this time. And actually, let's say 2. Okay, let's actually subtract these, not add them. All right, so can we subtract these radicals? Do we have the same index and the same radicand?
Yes.
Yes, so we have the same number here, 3 and 3. We have 5 and 5. That's good. Just going to subtract these numbers of 7, take away 2. Okay, so 7, took away 2, and then radical 5. Don't forget the index, and that will be 5, radical 5 of 3. Okay, that's very important. If you don't have the same radicand and index, you can't add. For instance, if you have radical, I don't know, maybe 7 and this plus some other radicand, for example, 7 and 3. You see here, the index is different. Index is 3, it's 2 here. Even though the radicand is the same, this can't add. Okay, can't add these radicals. So if we can't add two radicals right away, we try to simplify each one by itself first. Try to simplify this if possible, then simplify this, and after that you may end up with some like terms to combine. We can't break this down any further than 7. If you try to simplify it, there's no two numbers to multiply to 7 other than 1 and 7. Same thing here, so we can't simplify. But sometimes you may have, let's say, radical 9, maybe plus radical 8, index 3. Can we add these two right away?
No.
We can. Why not?
Simplify because the index is different.
That's right. The index is different. Also, the radical is different. So we can't add right away. But can we do something else before adding?
Simplify.
That's right. So we're going to simplify this. We know that the square root of 9 is
3.
3 plus the cube of 8.
2.
2. And now we can add these two. Okay, that's how the addition and subtraction of radical works. You gotta have the same radicand and index first. If you don't have them, try to simplify each one first, like we did last time, and then you could end up with something like this. Or sometimes these might not be perfect. For example, if you want to add radical 8 plus maybe
So how come you can't add the other problem, Professor, the one before that?
Uh, this one?
Yeah, with the sevens. How come?
So we couldn't simplify it, and we couldn't add. Basically, it stays like this. Okay, it stays the same.
Okay.
That's just like that. And for this one here, again, always try to add right away if you can. As you can see, we have different radicands, even though the index here is 2 and 2. But let's try to see if we can simplify. Can we simplify this radical 8 like we did last time? Radical 8, we can turn it into two numbers that multiply to 8 are 4 and 2 plus 5 radical 2. This can't be broken down, it's already simplified. Now this turns into 2 radical 2 plus 5 radical 2. Can we now add these two?
Yes.
Yeah, so 2 plus 5 of the same thing. Okay, think of it as, for example, 2 times plus, or 2 of the same thing plus 5 of the same thing. Just like when you add variables like this. So you gotta have the exact same thing here, like terms, before you can add them. So now we can add these two together. So 2 plus 5 is 7 radical 2. So simplify for, if you can't add or subtract right away, simplify first. So it shouldn't be that hard adding or subtracting. Just make sure you have the same radicands. By the way, you may have one of these, or you may have more. It could be 3 or 4 of them. Just do the same thing. Simplify all of them as much as possible. And then once you end up with similar radicals, you can combine them. Let's take a look at another example, maybe with multiple. Okay, so square root of 15 minus maybe 3 radical 5 plus radical 45. Okay, as you can see here, we have 3 radicals. Can we add them right away? Can we combine them right away?
No.
We can't. We do have the same index, but the radicands are different. Again, it has to be the same thing here, just like when we combine like terms. But we can simplify. We're going to see if, when we simplify each one of them and see if we can end up with similar radicals like these. How can we simplify this one? First one here, radical 50. We don't know the radical of 50, but we can turn 50 into two numbers. One of those numbers has a perfect radical.
5.
What numbers multiply to 50?
5 and 10.
5 and 10 will not help because we don't know the radical of 10, we do know the radical of 50. So
Okay.
what are the numbers that we used last time for 50?
25 and 2.
That's right. We use 25 and 2 because this can be turned into a 5. Radical 25 is 5. Radical 2. So this one is completely simplified. Can we simplify the second one? It's already simplified. Okay, and bring it down here. Finally, this one. Do we know the square root of 49?
7.
Okay, actually, I meant to put 45, not 49. Let me turn that into 45. 49 would have been easy. We don't know the square root of 45, so we're going to turn it into two numbers and multiply to 45. Which numbers? Everybody, what numbers multiply to 45? One of those numbers has a perfect root or radical.
12.
8, 7, and 8.
No, 7 times 8 is not 45. We have 15 times 3, and we have 9 times 5. Which combination do we use? Which combination is good to get a perfect radical?
9 and 5.
9 and 5.
That's right, because we know the radical of 9. 245 into 95 plus this turns into 3, and this stays the same. Can we now combine all these radicals?
Not yet.
Okay, at least these two can be combined, right? So
Yeah.
this stays the same. Okay, let's combine these two. They're the same. So -3. What happens to these two?
That's 0.
That's right. -3 plus 3 is 0. So these cancel. You end up with this. Or if you end up with the same radical here, for example, radical 5 here and here and here, you combine all of them. Okay, so before you add, try to add the radicals and subtract right away if you have the same, okay, must have the same radical. Same index. And radicand. To add or subtract. If you don't have those, try to simplify first and then add or subtract. So this applies to both addition and subtraction. Okay, so pretty simple stuff. It's based on what we did last time. Now let's go ahead and talk about multiplication. Multiplication of radicals. When you have two radicals, you remember last time, or just now actually, you remember how we turned this 45 into two radicals? You can actually go back and multiply the two. So if you have two radicals like this, you can multiply them back. You can break it down like this or go back. For example, if you see an operation like this, it says multiply these two. It's very simple. Just multiply the insides or the radicands. 9 times 5. And you get 45. But this only works if you have the same index. Okay, you gotta have the same index, not necessarily the same radicand. For multiplication, don't worry about the inside, it doesn't have to be the same, but these have to be the same. What is the index here, by the way, of these radicals?
2 and 2.
That's right, they're both indivisible, 2's. And that's it, that's the product of these two.
So can we simplify that?
The 3 for this one first? Yeah, that's possible.
Okay.
Okay, but sometimes when you can't simplify, let me give you an example that makes more sense. So if you have radical 2 times radical 8, what is this equal to?
16.
That's right, radical 16, which is?
2.
Radical 16 is?
4.
Just 4, hey, just 4.
Yeah, 4.
Here is 16. You may also have different radicands, rather. Let's say, maybe you have 9 here, maybe you have 3. Okay, can we multiply these radicals?
Yes.
Okay, you gotta have the same index, which is good. Then we're just gonna multiply the radicands. Which is the cube of 27. What was the cube of 27 again from last time?
9. Oh,
Oh, 9.
3. No?
3, right?
Yeah,
Radical is 3. Or if you could simplify first, that's also possible. If you can simplify this first. If you can't, you multiply right. That's what happens when you multiply two radicals.
Yeah, on your first example, can we have an answer of 3 square root of 5 then? On your first example. Yeah,
You
that
could, yeah, you could do that. You could simplify it.
3 square root of 5.
You could have simplified here first, but I just wanted to take this example to emphasize.
Yeah.
Sometimes also you may have, let's say we can multiply these two. So all these here are multiplications. what if we have something like this? Can we multiply these two right away?
No,
We can't. Why is that?
because it's different index.
That's right, different indices or indexes. Okay, if we can't multiply right away, what should we do?
Simplify.
Simplify it first. What is the cube of -8?
-2.
-2, that's right, as you saw last time. And
2.
number, that's right, 2. Number that multiplies by itself 4 times to get 16 is 2. And you get
And-
-4. Okay, so that's what happens when you multiply radicals. It's also possible to multiply a number and a radical. This number and this does not have a radical. This has a radical, so it's not 3 times 2, it's not 6. This one doesn't have a radical. Think of it as 3 times x. So this will be just 3
square root of 2.
3 radicals. That's right. Just basically write them next to each other. 3 radicals. Do not multiply 3 and 2 because this one does not have a radical. You have to have the same radical, same index in order to multiply the radicals. This is not a radical number. Just multiply that. Now let's see if we can combine these all together, for example, like this, and maybe radical, let's say 3 minus 5. Okay, so we have a distribution here. Just like we distribute algebraic expressions, we can distribute this like this. So radical 2 times radical 6, what would that be? I mean radical 3.
6.
So that would be radical 6, and then radical 2 times radical times
10.
5.
No, we don't multiply 2 and 5 because 5 doesn't have a radical. It just be 5.
Square root of 2, yeah.
Okay, so just radical 5. Be careful here. A lot of people make this mistake. 2 and 3 they multiply because they both have a radical of the same index. 2 and 5 do not multiply. This one does not have a radical. Back to this one. It will be radical
Square root of 6.
6. That's right. Minus
5.
5 radical 2. Then you try to simplify or combine in like terms. Can you subtract these two radicals now?
No.
No, they have to have the same radicand, same index. You could try to break the 6 down. You can break it down into 2 and 3 like this, but none of these has a perfect radical. So basically that stays like this. Don't worry if you end up with 2 or 3 radicals that can simplify, that's fine. Okay, only combine like terms, just like doing x, y, z. This stays the same, you don't add it. Same thing with the with radicals, radical 6, radical 2. If we have, for example, another radical, radical 3, there's nothing you can change here, that stays the same. Okay, now let's see if we can, okay, let's do a radical times 2 radicals. Maybe radical 2 here. Okay, radical 8 minus or plus radical 2. What is this equal to if you distribute?
16.
Right, radical 16 plus,
4.
that's right, 2 times 2 is 4. Can we simplify the result?
Yeah.
Okay, the radical index 2 of 16 or the square root of 16 is
4.
plus
Square root of 4.
4.
Plus
no, plus 2. Square root of 4 is 2, and that's 6.
6.
Okay, so it's pretty simple to multiply radicals. Again, make sure you have the same indexes, otherwise you can't multiply. Now let's see if we have a distribution. If you have like a FOIL thing, like 2 radicals times 2 radicals. Let's say we have radical 3 minus radical 5 radical 3 plus radical 5 again. We got a lot of multiplications here. We're going to use the foreign method to distribute. So radical 9. Okay,
9.
that's right, radical 9 plus radical
15.
15,
Then
Negative.
15,
negative radical 15 again,
And then 25.
and
Negative 5.
plus radical 25. Always try to simplify your multiplications. Can we simplify this?
Yes. 3.
Okay,
Cancel both. 15.
exactly. So these cancel out, as you can see. It's the same radical, but plus and the minus. It's like, for example, positive 2 minus 2. So those are opposites, they cancel each other out.
Yeah.
Or plus x minus x. So those are gone. And plus the square root of 25. That's right. 5 is 8. Okay, so pretty much very similar to multiplying algebraic expressions, but again, be careful. Sometimes you multiply the number, sometimes you don't. They both gotta have a radical of the same index, otherwise you won't be able to multiply. And let's see, I believe, see if there's some other different examples here. That's pretty much the same way we do all the other stuff. Again, just check your radicals first before you do anything. Any questions, everybody, about any of this so far? Everybody, please let me know if you have any questions. Again, most of this we discussed last time in the previous lecture in detail when we introduced radicals. You will find that lecture in the homework folder. Or probably at least the older one, but I'm gonna post the newer one soon. Let's see if there is some other different problems to go over. Yeah, basically it could be a mix here. It doesn't have to be all radicals. You may have a mix of some numbers and some radicals. Let's say radical 2 minus 3 and maybe a radical 8 plus, I don't know, 5 or something. Okay, it could be a mix of everything. Just distribute, and again, be careful when and when not to multiply the numbers here. So first, you do want to write all the multiplications. If you want to write all the multiplications first, so you have radical 2 times radical 8. You can write those in front of you first, and then multiply in the next step. What else after that? Radical 2. What's radical 2 times 5?
5 square root of 2.
That's right, 5 radical 2. And we don't multiply 2 and 5 because 5 doesn't have a radical. And what else? Everybody here?
Negative 3. Radical of 8.
That's right, negative 3 times radical 8. Again, this one doesn't have radical. We basically write them next to each other. And
then negative 15.
that's right, negative 15. Don't forget to simplify. So this is radical 16
Plus 16 plus
plus
5 square root of 2.
5 square root 2, that's right, minus 3 times. Can we simplify this radical here? Right.
No.
We don't know the square root of 8, but
Yeah.
we can probably break it down into
4 and 2.
That's right, radical 4 and radical 2 minus 15. Back to this.
4.
Right, 4 plus.
5 square root of 2.
That's right, minus 3 times.
2.
Right, 3 times 2, radical 2 minus 15. Continue simplifying, so it's basically 4 plus 5 radical 2 times these two numbers. So 3 times radical 2, which is radical 4, which is 2. That's
6
6.
squared minus 15. So just
Okay.
combine like terms.
Exactly. Now we can combine like terms. So we have this number we can combine with this. And we can combine these two together. 4 minus 15 will be,
11, negative 11.
that's right, positive 5 minus 6 of the same thing will be,
Negative 1.
that's right, negative 1
Square
radical 2, or simply negative radical 2. This one here is not important. You can write it without this. And that's your final answer. Again, we just distributing and simplifying. So we're combining what we learned last time with what we learned today to multiply radicals. Okay, everybody here, does that make sense? Did you have any questions?
None so far.
Okay, everybody else, are you guys all right?
Yeah.
Okay, so again, this is related to what we started last time when we introduced radicals. We spoke in detail about the indexes and simplifying and like terms and everything. Let's see, another example here. All right, here's another multiplication. Again, you just distribute, same way you distribute algebraic expressions. What's the first multiplication here?
5 and square root of 3.
That's right, 5 times radical 3. Again, we do not multiply 5 and 3. It's not 15 because this one doesn't have a radical. Then 5 times 2. It's 10.
Then square root of 9.
That's right. First, the sign, negative times the positive will be negative. And square root of 9.
Plus
Finally,
5. Plus 2. Article of negative 2. Article of 3.
that's right, radical 3. Simplify this a little bit. We have this radical 3 here, plus 10, minus,
Minus 3.
that's right. And this can't simplify, it stays the same. All right, let's multiply or simplify the like terms. What do we combine here?
3 and 5. Article of 3 and negative 2. Article of 3.
Exactly. So we have same index and the same radicand.
3, yeah.
That's good. We can subtract again for addition and subtraction. As I said here, we must have the same index and the same radicand for addition and subtraction. For multiplication, we just need the same index. So luckily here they look alike. So 5 minus 2. Let's actually write them first next to each other. Bring this over. And these, of course, combine here. So we can do 5, take away 2. So 5 of something minus 2 of the same thing. It's like if you had an x here, for example. This will be not 5, but 3 radical 3
Plus
plus
7.
7. And that's your final answer. Again, we do not add these because there's no radical here. If we have another radical here like this, we could add them, but these are different. We do not add 3 and 7. This is a radical number. This is a whole number. They're not like terms. They stay the same. This is like adding x and y, or 3x, for example, and y. We can add them. They stay the same. So that's basically what this is. That's pretty much all there is for this. Division takes a little more steps. We have something called the rationalizing. We will do that separately next class, along with, I believe, some equations. Yeah, we'll do that along with solving radical equations next time. But actually, let's see. Let's see if we can cram this in here today. Division of radicals, rationalizing radicals. 8.5. Let me see what part is it. Everybody, please let me know if you have any questions so far. I feel like we can add that here. You know, we can add the division here. It's not too complex. That'll be the last part here, division. So we can on equations next time. The division of radicals. It's mostly based on multiplication. Division is going to be basically 80% or 9% based on the stuff we just did. So it's better to do it now. There's something what we call pretty much everything we saw with multiplication applies to division. So you may have, let's say, square root, for example, of 25 over 4. This is a whole fraction. It has one radical. We can split these into two radicals. Radical 25 over radical 4. Okay, we couldn't simplify here. We try to simplify the fraction if possible. If not, you can break it down into two radicals as we learned last time. And what is this equal to now?
5 and 2.
5 over 2. That's right. And this is done. It also works if you have, let's say, different, say 8 over 27, for example, and you have a different index. Okay, so what do we do here, everybody? How do you divide this radical?
Separate.
So again?
Separate. Like cube of 8 and...
That's right,
Over.
cube of 8. So we can split this into two radicals, cube of 8 over the cube of 27.
2 and 3.
That's right. So the cube of 8, as we saw last time, is 2. Cube of 27 is 3. You can also go back if you want to combine two things together. So you have maybe something like this. Before that, if you have, for example, radical 8 over radical 2, here we kind of split these. We broke them down into two radicals, or you can also put these two together, just like multiplying. When you multiply, for example, radical 2 and radical 3, this is radical 2 times 3, which is 6. Make sure you have the same index. You can also apply that to division. You can put these two together, just like we did here. We can divide 8 by 2, which is radical 4, which is 2. Okay, same concept as the multiplication. Now we're going to talk about something called rationalizing. This is a lot of interest in here. Remember the word. What this means is to rationalize a radical is basically to get rid of the radical from the denominator. That's all it means, to get rid of this one way or the other. We want to remove this from here. We don't want it. It can still be here, but we won't be here in the denominator. So this basically means removing the radical from the denominator of a fraction. Okay, so remember that word? Just means removing the radical. And it's pretty easy to do. let's say you have 2 over radical 3. So to rationalize this fraction here, we want to get rid of the 3. To get rid of the 3, we simply multiply it by itself. So you take the fraction again. So to get rid of any radical, for example, here we just times it by itself. Because when you times radical 3 and radical 3, it will be radical 9, which is, turns into
3. I mean 9.
That's right, radical 9, which is 3. So that's all you do to get to rationalize this. And make sure if you multiply the bottom of a fraction by something, the top you multiply by. You're going to multiply by the same thing to get an equivalent fraction. So whenever you multiply one side of a fraction by something, you have to multiply the other side. That way you keep the ratio the same. You keep the same proportion here. Otherwise, you change the fraction. Okay, so just times the radical by itself. Don't forget the top. What's 2 times radical 3?
2 radical 3
That's right.
over
We said this will be radical 9, which is 2 radical 3, and radical 9 is 3. You see, we no longer have,
no.
that's right, we no longer have the radical here, and that's what rationalizing is. It's not a problem. It's not a problem the radical is here, but it's no longer here, and that's what rationalizing is. Again, just times the radical by itself. Okay, pretty simple. Let's do another one. Okay, we want to rationalize this. Which radical do you want to get rid of?
The 2, the denominator.
That's right. This one here, radical 2.
Mm-hmm.
So we don't care about radical 5. We want to cancel radical 2. And how do you cancel radical 2 again?
Multiply by itself.
Exactly. So we're going to times this by radical 2 on the top.
Times radical 2.
Exactly. The same thing as here. Not here, but the same thing as here.
Yeah.
And the rest, again, is just multiplication. That's why I said division of radicals is very similar to this. So we're going to pretty much multiply again. This is radical
10.
That's right. Radical 10 over
4.
radical 4, which will be
5.
here. Radical 4 is 2. Again, as you can see, we no longer have this radical here, so that means we rationalized this radical. It's pretty much based on multiplication, like I mentioned earlier. Are you guys all right, everybody here? I don't hear from all of you. Is everybody okay?
Yeah.
Yeah.
Okay. Again, please let me know if you have any questions. Let's make things a little more interesting here. You could have more stuff, not just one radical here. You may have, for example, radical of this, maybe radical 7 plus 1. Again, the purpose of rationalizing is to get rid of this radical from here. So what do you think happens here? What do you think we need to do in order to get rid of this radical here? Multiply by what?
By 7.
So we're going to take that and we're going to multiply it kind of by itself, not exactly like this. We're going to multiply it by itself, but we're going to switch that sign here. Okay, so we're going to times it by itself. We're going to understand why in a minute. Okay, so you take that, make sure you flip the sign here, and also multiply the top by the same thing here, which is radical 7 minus 1. And the rest again will be just basically distributing, just like we did earlier. So we have one multiplication here, another one here, just basically a couple of these, something like this and something like this. Okay, so let's distribute the first one. So 3 times radical 7, 3 times -1, over radical 7 times radical 7, which is radical 49, then -1 radical 7. What else?
Plus
Plus 1 radical 7.
minus
Finally, -1. After multiplying, always try to simplify. What happens here? We can't do much here.
yeah.
It doesn't have a radical, so that stays the same. What about the bottom here?
7
7 and
cancel and then -1.
that's right. So these cancel out. That's the reason we switch the sign here. If we don't switch the sign here, these two will not cancel out, and you'll still have a radical here. And that's the opposite of rationalizing. So make sure you switch that sign. That way we can have these two, the middle terms cancel out, and then this stays -1. That's basically 3. Radical 7 minus 3
Over
over
6.
6. There's one more thing we can do here. Can we simplify this a little more? Everybody think about factoring.
Yeah. -1 over.
We can factor this 3 out. Basically put it back where it was. It was like this. I'm going to put that 3 back here so we can cancel it against the 6. We can simplify it against the 6. So we're going to factor here. 3 as a common factor. Basically, it's going to be back to this over 6. Now we can reduce this by 3. It would be radical 3 minus 1 over, if you reduce this by 3 would be 2. Okay, don't forget to do that whenever possible. You can factor if it is a common factor, just like we did with the rational expression, factor, and cancel out. Okay, so that's pretty much as complex as it can get with the radicals. When you have two things here, not just one. So multiply by itself, but don't forget to switch the sign, multiply and simplify. Again, the keyword here is rationalize. So when it says rationalize, you just need to get rid of the radical from here. Let's do the last example here. Okay, let's do, for example, radical 2, radical 3 here, plus or minus radical 7. Okay, we want to rationalize this whole thing. What do you think we do? We're going to multiply this by what?
3.
By what? If you want to cancel the radical from here.
Multiply it by both radical 3 plus radical 7.
That's right. So we need to multiply this by itself, kind of like by itself, but with a plus here instead of a minus. So it's going to be radical 3 plus radical 7. And the exact same thing here at the top, it will be radical 3 plus radical 7. And the rest is just, again, multiplying, like I said before, just based on this. Let's go through this. So this is radical 6, radical 14, over radical 3 times radical 3, that's radical 9, which is radical 9 is 3.
3.
Then you have radical 3 times radical 7,
21
21, that's right. Then
plus 21.
this one would be negative radical 21, and
49.
that's right, negative radical 49, which is
7.
7. This can't add, as you can see here, because the radicals are different. You can try to break this down, but You can do 3 and 2 here, but none of those has a perfect radical. You can do 7 and 2 here. None of those has a perfect radical. So this basically stays as is. And back to this. These go away. 3 take away 7. It's -4, and that's basically it. Nothing to factor here to cancel out. That stays the same. And that's basically all your operations with radicals. Starting from the previous class, we learned what radicals are, the index, the radicand. We learned how to simplify. And today we'll learn all the operations basically, addition, subtraction, multiplication, and division. And we're going to utilize all these when we solve some radical equations next class. So this takes a lot of practice. And again, rewatch the videos if you have issues. I'll post this video also, along with the video for last time. Okay, everybody, any questions?
None.
Okay, so the radicals are not that complex, pretty simple. Everybody else, any questions? Any questions before we move on to the quiz?
None so far, Professor.
Mm-hmm. All right, so that's pretty much it for this lecture. Give